Well, good morning, everybody. It's great for me to be here. Some of you know me. Some of you are familiar. I used to live here a long time ago, and I haven't been here in a while. COVID was part of that. But this morning, it's great to be in a room with all of you who have a passion for strategic mine planning as I do. And I'm going to show you some things today that are kind of an approach to handling something that's very important to a lot of mining companies today around ESG. Before I begin, a little disclaimer though, I am not by any stretch an expert in ESG. I'm a mine planner, and so the way the presentation is formatted, the content, it's all looking from the perspective of a mine planner, seeing things that are happening from an ESG mandate perspective from our enterprises, and wondering what we can do about it. Okay? You don't have to look very far or look very long on the internet to see that ESG and decarbonization is a big issue and is taken very seriously by a number of the big mining houses. I've taken a few examples there, and you can see there's different flavor, there's different timing and different magnitude, but they're all heading in the same direction, and they're taking decarbonization very seriously. Some of you work for some of these mining houses and you know this more than I do. So the question today is how do we deliver to those commitments in strategic planning? All right, we saw the years, like in 10 years time we need to be at 50% reduction. How do we do that? If we're doing strategic mine planning, that is well within the horizon that we're dealing with. So I'm going to show you an approach. The good news is that we can do some things and we can solve this problem using current technology. All right, this isn't something that's down the track. It's not something that's in R&D. It's something that's available now. Okay, and it's available through Minemax Scheduler. This is a software that Minemax has had for over 20 years, and it has got a number of pieces to it that allow the solving of these types of ESG challenges at the same time you're solving the mine sequence. Okay. For those of you not familiar with the software, it's a strategic mine schedule optimization software. It solves for the mining sequence, cutoff grade, destinations, CapEx optimization, all simultaneously. All right, and it's going to do that while it seeks maximum net present value for your project. So ESG is a new modeling challenge that is approachable through this software, and I'll show you how. There are multiple sources of emissions, so we're going to focus on decarbonization of ESG. Multiple sources of emission throughout the mine site. Today I'm just going to talk about truck emissions, right? It's one of our biggest sources of emissions, and it is something that is very important to get right in a mine plan. Most of you are mine planners, and you've done strategic mine plans. You're incorporating trucks because of that variable haulage, that dynamic that happens over time. It has a big impact on your ability to deliver an operational plan. And if you've modeled it appropriately in the strategic context, then you know you have a deliverable, operable plan. So we're going to build upon that exact framework of that haulage in strategic mine planning with some additional things. We're going to model our scope 1 emissions and our fuel consumption for our diesel trucks. All right, we can do that through the software. Then we're going to treat the total scope 1 emissions as a constraint. All right, so I showed you some examples earlier of some mining house enterprise level emissions goals. And what we're going to do is say, okay, in 5 years' time, we need to be at 50% reduction. We're going to set a maximum constraint of the total carbon that this plan can produce. And we're going to optimize within that framework. Many of you are probably thinking, well, that's just going to mean that we're going to be parking up trucks, and before you know it, the mill is half full, right? That's a problem. Not exactly a plan that you want to deliver. So there's another piece of this which is equally important, and that's optimizing the capital expenditure for alternative fuel haulage vehicles during the schedule, knowing that constraint. All right, so it's a matter of timing and instancing for those CapEx spend. We're also going to do a neat thing here where we're going to incorporate some offset options, so buying carbon offset credits on the open market. And all of those as options for the schedule to choose while it's maximizing MPV. All right. So I've got some software UI I'm going to load up. It's videos embedded in the presentation. I'll show you how we do this. All righty. So setting up a model. All right. So the first thing we're going to do is we're going to set up the model. And I mentioned we're going to be using an existing model, which is a metals project, which has a couple of things going on. We've got a mill and waste decision, which means that we're going to solve for the destinations of the blocks. And then, of course, we're going to have all of the trucking processes downstream of that, which are going to be representing both the alternative fuel vehicles and the existing diesel truck vehicles. Okay? And downstream of the diesel truck vehicles, we're going to also be modeling fuel consumption, and we're going to be modeling emissions production. Then we're going to have some calculated processes, which are going to take and sum all of those relevant processes in the right direction so that we can constrain that total emissions. As I mentioned, that's going to be one of our key constraints, which is going to guide the schedule. Okay. All right. This is a challenge here. I like it. All right. The next step is configuring haulage. So you can bring in cycle times externally into Minemax Scheduler if you have them already, or you can use the onboard tool. If you bring them in externally, they can be block model attributes, or they can be in lookup tables. As long as you're covering the full spectrum and you're bringing in your cycle times for every possible destination for every block, it'll work. If you use the workflow, it's pretty simple. You follow the steps. You define your truck types and your speeds and your capacities, all of your gradients for speeds, and all of your delays. You bring in your strings that are external, that are going to put together for your ramps and your roads. You define your entry and exit points, and that's for all of your sources and all of your destinations. Okay, so this way you have a route network, and what Minemax Scheduler will do is upon import, it's going to calculate the cycle times using those inputs and populate all of the cycle times for all the destinations. Okay, pretty straightforward stuff. And then we import the data. Okay, those of you who used Scheduler before, you're familiar with importing data. We can accept CSVs and text files, and we can import data mine native block model formats. The key of what is going on here, the essence of what is going on is we're building an import configuration. Okay, that import configuration will take a known set of data that can change, but if the format of the data remains consistent, and the expressions which are used to calculate new variables, which might not be in the input data, are remaining static. Okay, so in terms of the emissions model, we're going to be generating not only the cycle time calculations that you can see there, but also the fuel consumption, which will end up in total liters per block per destination, and also the emissions generation, which is going to be on tons of carbon produced. All right, we have two import configurations if you're doing integrated waste dumping. One for the pit side and one for the waste dump side. And so this is importing data. All right, and the next step is reviewing reserves. Okay, just those of you again who use Minemax Scheduler, you're familiar with this. We take a lot of support calls that end up actually being a function of perhaps an issue in the mapping early on during the import that wasn't caught in the reserves, and they started scheduling and they started investing time in optimization, and they realized that, oh, wait a minute, I've got a problem, they're phone us up. So what we've been doing is an additional development in the reserve validation step of the whole workflow. So once you've imported your data, we have a new filterable reserve table which you can isolate and drill down into individual processes and attributes in your model to see what's relevant and to validate it before you go any further. Because no one wants to lose time, right? As far as emissions is concerned, on the video you can see that I've got some emissions processes, and the validation for this would be I'm going to load up just those emission processes, perhaps the truck hours as well, so I have some correlation. And then I can look at an individual phase or an individual phase bench basis to confirm whether or not those are correct. Okay? And you can do this as well on the waste dump side. All right. On the waste dump side, the emissions are going to be from essentially the haulage that is from the toe of the waste dump ramp into the lift, right, or into the cell of the waste dump. All right. The next step is configuring scenarios. This is where all the fun happens. This is where everybody likes to spend their time. I've configured a number of scenarios here, and a lot of scenarios is good because then you can see sensitivity to parameter variation and all of those things. I'm just going to walk you through the last one, and the reason for that is that it's incrementally built up, okay? So this is an annual mine plan. This is a strategic mine plan that is scheduled in years. It's important to have a financial model built right and accurately because that is going to drive the behaviors for NPV. In this particular model, it is a metals mine. We're producing revenue on the basis of tons of metal produced. Tons of metal is already factored in for the recovery, so that's why it's there. And then I have a number of unit costs at the bottom, some of which I'm pulling from the model, like end caps and whatnot. And of course, I have truck hour costs, $2 per truck hour. So I have an activity-based cost model that is expressed in unit cost. And you can see that I have two different types of truck hour processes there, which are in their groups, one for the alternative fuel vehicle, one for the diesel truck vehicle. We have fixed costs, right, period-based costs. We have it both on the mill, 50 million per annum when you run that thing, and also on the alternative fuel vehicle, because what I'm going to model here is a battery electric truck as a CapEx option, and it's going to have a $15 million per annum charging station at the fixed point, at the fixed cost. Right? This is the CapEx definition. I have a diesel new truck, which can be purchased, or a replacement truck for $5 million, gives me 8,000 hours. Okay, these are just round numbers. I also have an alternative fuel vehicle, which is a battery electric truck. Also, is 8,000 hours, but it's at twice the price, 10 million. And then lastly, the CapEx instance for our carbon offset credit, which for about 8K, you get 100 tons of extra credit above your threshold. Okay? All of these CapEx options, they're all available. They're not mutually exclusive, which means I can have any combination of them. I don't know when they're going to happen. The optimization is going to solve for that. Okay, how many, if, when, and the combination. Precedences, it's a phased pit, so we've got to have some precedences. The constraints, very important piece, right? This is meat and potato stuff. We've got a mill that has a capacity of 30 million tons per annum in this case. It's a very simple project with a single mill. I have a different constraint as well, which is going to manage variability from period to period if I need it. I also have a constraint on my existing diesel truck hours, and that is going to be a declining curve over time, right? So I got an existing fleet. That fleet's going to spend more time in the shop. I'm going to need to replace them. And that constraint you see that's circled there, that's the emissions constraint. It kicks in year 6. And I have an alternative fuel constraint on truck hours, which means that I have a zero maximum. There's none on the ground right now. I have to find the optimization of the select. And lastly, a tonnage constraint based on shovel capacity. In addition to that, I have the vertical advance constraint, so I can control the number of benches in every phase for every period. Right, so we've got a lot of different constraints. Some of them are spatial, some of them are general, some are related to the CapEx. The way the CapEx works is it's going to leverage a known constraint to release it up to a certain magnitude if it creates more value for the project. And no is always an answer, right? Zero CapEx spend is always an answer. All of these are going to work in parallel, and they're all going to be honored, okay? Some of them, like the carbon offset credit, which will increase the amount of carbon that you can put into the environment over your threshold, you'll see how that affects it when we get to the result. And again, apologies for this, but we'll get there. Okay, results. So just a few visuals, some dashboards that we've developed. These, of course, are all customizable depending on what you want to see when you finish your scheduling. There's 3D visualization where you can see the pit being mined out and the waste dump being built. There's a material flow diagram. There's a pit by pit stack bar chart there on the top right, which shows all of the phases being mined and a constraint on it. Of course, this is your mill tonnage going into the mill. It's nice and consistent, so we know that the scenario is delivering to what our expectation is. And this one, this is the CapEx dashboard that I've developed. This is the revealing one. It shows you precisely which CapEx instances, and that is really foggy. See, the top one is diesel trucks. The middle one is your battery electric vehicle, and the bottom one is your carbon credits. And you can see how those are coming in across, and the timing of those has been optimized. All right, the bottom chart is the diesel truck hours in blue, alternative fuel truck hours in yellow, and the emissions in that blue line. So you can see how it came down and remained down. A constraint chart, or constraint table, I should say. These are really important for any optimization modeler. They can see what's going on. If they're highlighted in green, that means that that particular constraint is binding the schedule. And you can see in some periods there are multiple constraints binding the schedule. Right? If it could produce more than 30 million tons at that mill, it would make more, so that's a binding constraint. Right? Pretty cool stuff. All right. So in summary, this is just a simple model of truck emissions. And what we've done is we've gone a step further than truck hours, and we've modeled the activity-based contribution of truck sources of emissions. And we've modeled that so that we know that the dynamics of the schedule are going to calculate additional emissions depending on what the schedule is deciding to do. Right? And then we've created a process which is going to sum all of those different emission processes, right? We call it a calculated process, in the appropriate direction. So if you have stockpiling, reclaiming, all of those things. And that will be the process for the total project of total emissions that we're going to set the constraint on. All right, so we're going to treat our corporate mandate of a certain amount of tons carbon as a constraint, a hard constraint. Then we're going to solve for the investment related to CapEx for alternative fuel vehicles. So they could be hydrogen cell vehicles or battery electric trucks, maybe something else, okay? But we're going to solve that at the same time because we see that mandate coming down the track. We have an existing diesel implementation. We know our diesel implementation is going to age over time. So the timing of how we're going to feather that in with new prospects, or excuse me, new purchases of vehicles will be solved for at the same time that sequence is generated. And it all gives you some more confidence in what you're putting forth as a mine plan is going to secure the goal for the company, and it's got a viable plan that is supported by your haulage dynamic. All right. So other aspects. So this is just truck emissions, right? So you could go further and you could model some of these other things. The other mobile fleet scope one, right? So dozers and all your ancillary shovels. If you have a complete diesel implementation, you could also on a block by block basis model the emissions production when that block is mined, right? And you could build that up, you could add it into that calculated process, and then you would have a total project-wide emissions. And what that would do is if you are, you know, obviously diesel, battery electric trucks aren't available in the market today, and you want to know, okay, there's going to be some limitations there. I have more confidence in the total project-wide emissions and how many I'm going to need to purchase if I do that extra step. Power consumption. So this is kind of a scope 2 sort of thing, right, where my electricity, which is driving my mill, for instance, is generated giving scope 2 emissions from coal-fired power plant or something. We can model the power consumption on a block-by-block basis as well, right? So when a block gets processed, if we have a buildup which is related to, say, grindability, which is preferential, we can blend to a certain amount of power consumption as a constraint, in which case your enterprise can then deliver on that power consumption window. Water consumption is kind of the same thing. Community investment, likewise, you can use some of that really smart CapEx optimization to determine if I'm going to get into this new mining area, this new green field, and it's a timing thing, and I've got existing brownfield around it, but the precedence for that particular greenfield is that I have to invest in a community infrastructure of however many million. Well, that has an impact on the total schedule, right? If everything is being fed through a common plant, if they're using common mobile equipment, if you're modeling and integrating that together, optimizing the timing of that community investment, considering the value that that greenfield will unlock, again, that is something else ESG related that is solvable in the software. So I think that does it. I could keep going, but I don't think that would be good. I appreciate your patience with my technical problems. I appreciate your attention to my rambling on. Hopefully it's been worthwhile for you, and I'm happy to take questions.
The trend that you saw with the diesel fleet transition to electric to credits, is that something, I don't know, is that a general trend? Mine's going to be needing to purchase credits in your view?
You know, it's going to vary. It's going to vary. I don't know exactly how it's all going to play out, if the credits will be acceptable for the corporate mandate for certain enterprises, right? In this case, I wanted to show it as a modeling dynamic that has an additional way of optimizing something, right? So in many cases, it may be that you must meet that threshold or be below it, in which case the carbon credit would be off the table.
Does it possibly change your pushback sequencing when you try and achieve these different targets, or you need to import a fixed pushback sequence?
So the design, so in this case, the design is fixed, but the sequence has changed. Yeah, so the sequence would absolutely be influenced by all of these things because it's being solved simultaneously. Yeah, so I might totally change the sequence on the basis of trying to meet emissions.
Does it consider
for backfilling? So this is an emissions credit? I guess if you have an arrangement with whatever you're doing there where the backfilling, even though you're generating emissions to put waste in the backfill pit, those are a credit towards something. You could make that work. Yep, you could set that up. We've done a number of backfilling models. None that have had a trigger on negative emissions backward into the schedule, but it's totally feasible. Yeah. Because that would, if you have a lot of small pits, right, and the sequence is mining from a lot of small pits, and some of them, if you speed up, you'll have a lower or shorter haul for a backfill, right? That sort of NPV-related, cost-related incentive absolutely influences the schedule. So if you have an additional incentive related to carbon, where you could offset it based on backfilling hauls, sure.
That's good. And carbon shapes.
Sure. Yeah.
Sorry for the many questions.
No problem.
So when you set up your scheduling targets, emission being one of them, if you've got a, let's say, 8, 9 multiple schedule targets, you actually prioritize them, and how does the scheduler handle that? In terms of trying to find or hitting those targets whilst optimizing NPV?
Sure. Yeah, so in this software, we're doing an MILP optimization. So we're not really targeting, we're constraining. And the constraints are hard constraints. So if I set a constraint there, which is a maximum constraint, I won't see any schedule that violates it, right? That constrains the feasible solution states, right? So I have multiple parallel constraints. The target, if you will, is a maximization of NPV. So it's going to look at all of the possible schedules that meet the constraints. It's going to throw them all out except the most valuable one. And that's the one it's going to give you. So if I add more constraints, that just means more schedules are no longer, right, they're inferior. They're going to go away or they're infeasible.
Is all that in our current versions now?
It is. It's available right now.
Great idea, good presentation. And where I came from, I got lots of bits. So
Yeah.
around 150 easy. So when we're dealing with this and switching to different type of rates, how easy is that to compare between the scenarios, like the sequence, how what it's doing, and the big sequence mainly, how can we examine between the two scenarios?
Okay. So the in your case, the number of pits and the reserves in those pits doesn't change. It's just a function of scheduling scenarios. Yeah. So in Scheduler, in the software that I showed you today, you can have multiple scenarios for the same project. So when I import my reserve, that remains static. And then a scenario can be cloned. So I set up a scenario, I like it, I clone it, and I change something. Maybe it's a mining cost. Maybe it's a CapEx definition. Maybe it's a constraint at one of those pits for access. And I re-optimize. All right, I'm going to get a different schedule. Because now I have an additional constraint, changes the model. And then you can compare those scenarios based on NPV or whatever other criteria you've got. Does that answer your question?
Yeah, and
Okay.
also just leading to another question, like maybe how can I easily, because it's really hard for me to check what bits are coming when we change the scenarios.
Oh, okay.
So say one bit, say bit A is coming in 2021 Q1. I got this 200 bits. So quarter 2021 bit A replaced with bit C.
Mm-hmm.
So is that easy to look at the bit sequence?
Yeah, so you can look at it graphically and you can look at it in a tabular way. So there's like pit by pit charts like I showed you, and there's also movement tables. So all of that is customizable. So whatever sort of information you want to put in a table, you can select those processes and you can decide to, plot it by pit or plot it by pit group. Right, so you have a heads-up display on which pits are coming in and when. If you got 150 of them, you're going to have quite a few different ones coming in, right? So usually people have a lot of different pits like that. We tell them, can you group them into pit groups? That gives you an additional way of mapping that and looking at it on a dashboard that's not just so crazy and cluttered. You can also take and export any of the tables or charts that you develop in Scheduler and export them out to Excel. Right? If you like doing things in Excel, most engineers do. So you can do it now.
Yeah, I think Excel is a good option, but still sometimes it's going to be painful because they have another.
Sure. Yeah, and I mean the other way to do it is if you have a particular pit in question, pit C, all I do is I use the filter and say just show me pit C, and I hope it comes in period 3. Yeah.
You mentioned calculation of fuel burn. You did set a function in Minemax because we're at the moment we're sort of going to external packages
Yes.
for calculation of fuel, and that's a critical cost input.
Absolutely.
I guess those third parties have validated their models with OEMs. Have you done the same?
No, so we are importing that information. So however you want to calculate it, OEMs, wherever, it's going to be accurate, bring it in as a lookup table or as a block model attribute. In the example I showed you, I just have some expressions referring to some constants that were based on some benchmarks, okay, because it's just an example. Absolutely, if you've got good fuel burn information that's accurate, you'll want to use that. It'll drive the costs and the emissions.
Can we do these calculations without importing to the block model? Can we do the calculation in Minemax?
Yeah, absolutely. So in that import configuration, that big screen that had the little expressions that nobody could read in there. So that's all custom, comes blank, right? So whatever is not in your block model that you need, you can calculate an expression and map it to the model there. So if you've got a really good block model that carries everything, you just swoop it in, right? All right.